The morning of May 14, 1942, at a makeshift firing range outside Manila, Japanese naval ordnance officers stood in the tropical heat, watching as technicians loaded captured American ammunition into testing equipment. Among the spoils taken from Corregidor 8 days earlier were not just thousands of M1 Garand rifles, but something more revealing. Crates upon crates of 30-06 Springfield cartridges, still packed in their original wooden boxes marked with American Arsenal stamps. The engineers had been sent from Tokyo specifically to evaluate this ammunition. They understood ballistics. They had tested countless rifle cartridges during their careers. But what they were about to discover would fundamentally challenge everything the Imperial Japanese military believed about infantry weapons design. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lieutenant Commander Takeshi Nakamura supervised the ballistic testing program. He had spent 15 years in naval ordnance, evaluating weapons systems for the Imperial Japanese Navy. He was methodical, precise, trained in German engineering principles at the Naval Academy. When he received orders to analyze captured American ammunition, he approached it as routine technical work. The Americans had surrendered Corregidor on May 6th. The fortress island had held out for nearly 5 months, far longer than Japanese planners had anticipated. Now, with Manila Bay finally secured, Japanese forces controlled not just the island, but everything the defenders had left behind. Weapons, ammunition, supply dumps, field manuals, everything needed to understand exactly what the Americans had been fighting with. The captured materiel was extensive. Over 10,000 M1 Garand rifles, hundreds of thousands of rounds of 30-06 ammunition, Browning automatic rifles, machine guns. The ordnance officers catalogued it all, but Nakamura's focus was narrower. He wanted to understand the ammunition itself, not just how it worked, but what it was capable of. The Japanese military used 2 primary rifle cartridges, the 6.5mm Type 38, in service since 1905, and the newer 7.7mm Type 99, introduced in 1939, to address perceived deficiencies in the 6.5. Both were good cartridges, well-made, reliable. Japanese soldiers had used them effectively in China, in Manchuria, throughout the Pacific, but Japanese commanders had filed troubling reports from combat against American forces, reports that didn't quite make sense. At Bataan Peninsula, during the fighting in January and February, Japanese infantry had faced unexpectedly heavy fire from defending Filipino and American units. Officers described it as sustained, overwhelming, unlike anything they'd encountered in China. Some reports claimed American positions were equipped with far more machine guns than standard doctrine suggested. That was the only explanation that made sense. Except intelligence officers reviewing captured American unit rosters found no evidence of extra automatic weapons, standard American infantry organization, standard weapons allocation. Yet, somehow, American defensive fire had been devastating enough to stop multiple Japanese assaults. Nakamura had read these reports. He found them curious. If the Americans weren't using extra machine guns, what explained the volume of fire? The 30-06 cartridge might provide answers. Not just what the round did, but what it was capable of doing. The Japanese ammunition could not. The test range had been established on a former American airfield. Bomb craters pocked the concrete runways, but enough open ground remained for ballistic testing. Japanese engineers set up firing positions at measured distances: 50 meters, 100 meters, 200, 400, 600, 800, beyond. They erected targets, man-sized silhouettes, wooden boards to measure penetration. They brought measuring equipment, chronographs to record velocity, pressure gauges, scales for weighing components, everything needed for comprehensive ballistic analysis. For comparison, they brought Japanese ammunition, Type 38 6.5mm rounds, Type 99 7.7mm cartridges. They would test everything side by side, scientific method, controlled conditions, document every measurement. The first American cartridge they examined was marked on the brass case head with clear stampings. LC 42, Lake City Arsenal, manufactured in 1942, recent production. The cartridge case measured 63 millimeters in length, overall cartridge length 85 millimeters. The bullet was pointed, boat-tailed, streamlined for aerodynamic efficiency. It weighed approximately 152 grains or 9.8 grams. The powder charge was IMR 4895, a modern smokeless powder developed specifically for the 30-06. Japanese engineers weighed multiple cartridges. Consistencies was excellent. American quality control appeared to be very high. Each round weighed almost exactly the same as the last. The bullet jacket was gilding metal, a copper alloy that reduced barrel fouling. The core was lead, standard military ball ammunition design. But the specifications were just numbers. The real question was performance. They needed to see how the cartridge actually performed when fired. The test team loaded a captured M1 Garand, 8 rounds from an unblocked clip. They positioned the rifle in a test fixture at the firing line, aimed at a target 100 meters distant. Chronograph sensors were set up to measure muzzle velocity. A technician checked the equipment. Everything ready. The first shot cracked across the range. The rifle's gas system cycled smoothly. The empty brass ejected. The chronograph recorded data. Muzzle velocity, 855 meters per second, 2,805 feet per second. The bullet struck the 100-meter target dead center. They fired 7 more rounds, all nearly identical velocities. Excellent consistency. At 100 meters, every round hit within a tight group. Accuracy was very good. Now they extended the distance. They set up fresh targets at 200 meters, 400 meters, 600 meters, 800 meters. The shooting continued methodically. At each distance, multiple shots. Record the data, measure the grouping, examine the target impacts. At 400 meters, the 30-06 bullets were still hitting with substantial energy. The wooden backing boards showed deep penetration. At 600 meters, performance remained strong. Grouping opened slightly, but the rounds were still delivering lethal force. At 800 meters, the bullets continued to fly true. The streamlined boat tail design maintained velocity much better than engineers had anticipated. Then they tested Japanese ammunition using the same protocol. A Type 38 Risika rifle, chambered for 6.5 millimeter. The cartridge was smaller than the American round. Case length 50 millimeters, bullet weight 139 grains. Muzzle velocity approximately 735 meters per second, 2,400 feet per second, lower than the American cartridge by a significant margin. They fired at the same distances, 100 meters, 200, 400, 600. At 100 and 200 meters, the Type 38 performed adequately. Accuracy was acceptable. Penetration was sufficient for infantry combat, but at 400 meters, the difference became apparent. The lighter, slower Japanese bullet had lost much more velocity than the American round. Energy at impact was noticeably lower. At 600 meters, the gap widened further. The Type 38 bullet dropped more dramatically, required more holdover for accurate shooting, maintained less energy at the target. At 800 meters, the Japanese round was approaching the limits of its effective combat range. The bullet was still lethal if it hit, but maintaining accuracy at that distance required exceptional marksmanship and favorable conditions. The engineers ran the numbers. At 800 meters, the 30-06 retained approximately 60% of its muzzle energy. The Type 38 6.5 millimeter retained only about 40%. That was a massive difference in terminal ballistics. More energy meant more certain lethality, less wind drift, flatter trajectory. The American cartridge was simply more effective at long range, by a significant margin. They tested the Type 99 7.7 millimeter. This was Japan's newer, more powerful cartridge, developed specifically to address complaints about the 6.5. The 7.7 used a heavier bullet, 182 grains, traveling at approximately 730 meters per second. The results were better than the Type 38. The heavier bullet maintained velocity more effectively. At 400 meters, performance was respectable. At 600 meters, it was adequate. But at 800 meters, the 7.7 still couldn't match the 30-06. The American cartridge's combination of bullet weight, aerodynamic efficiency, and higher velocity gave it a clear advantage. Nakamura stood at the firing line, reviewing the data sheets. The numbers told an unambiguous story. The 30-06 Springfield cartridge outperformed both Japanese rifle cartridges at extended ranges, not by a small margin, by enough to matter tactically. An American soldier armed with an M1 Garand, firing M2 ball ammunition, could engage targets effectively at 800 meters. A Japanese soldier with a Type 38 Arisaka was limited to perhaps 400 to 450 meters for reliable combat effectiveness. That was a 400-meter gap, 400 meters where American riflemen could shoot with confidence while Japanese riflemen struggled to return effective fire. The implications were profound. In open terrain, American infantry could establish fire superiority at ranges where Japanese troops couldn't effectively respond. In defensive positions, American soldiers could begin engaging attackers at 800 meters, forcing Japanese forces to advance through 400 additional meters of accurate rifle fire before they could shoot back effectively. 400 meters of killing ground, 400 meters where one side could shoot and the other could not. That translated directly into casualties, into failed attacks, into tactical disadvantages that no amount of courage or determination could overcome. But the range disadvantage was only part of the story. The engineers continued testing. They evaluated ammunition consistency. They tested different lots from different American arsenals. Springfield Armory, Winchester, Lake City, Frankfurt Arsenal, every lot performed nearly identically. Quality control was exceptional. American ammunition was standardized to extraordinarily tight tolerances. Japanese ammunition, by comparison, showed more variation between production runs. Some lots were excellent, others were adequate. American ammunition was consistently excellent. They examined the bullets themselves under microscopes. The gilding metal jackets were uniformly thick. The lead cores were precisely centered. The boat tail angles were consistent. American ammunition manufacturers had achieved a level of industrial precision that Japanese arsenals struggled to match. This wasn't just about design. It was about manufacturing capability, about quality control systems, about industrial processes refined through decades of production. The engineers calculated ammunition weight. An American soldier could carry approximately 120 rounds of 30-06 ammunition in standard bandoliers and en-bloc clips that weighed roughly 4.8 kilograms. A Japanese soldier carrying 120 rounds of 6.5 millimeter ammunition carried approximately 4.2 kilograms. Not a huge difference, but enough to notice on long marches. And the American soldier's ammunition was effective at twice the range. That meant each American cartridge was effectively worth more than each Japanese cartridge in combat utility. Nakamura drafted his preliminary report on May 20th. He chose his words carefully. Senior naval officers would read this document. Some might not understand the full implications without clear explanation. The report began with technical specifications. 30-06 Springfield cartridge, 7.6, 2 mm by 63 mm, bullet weight, 152 grains, muzzle velocity, 855 meters per second. Muzzle energy approximately 3,600 joules. Effective range approximately 730 meters for trained infantry. Maximum range approximately 3,150 meters. Then came the comparison to Japanese ammunition. Type 38 6.5 millimeter. Effective range approximately 450 meters. Type 99 7.7 millimeter. Effective range approximately 550 meters. The American cartridge outranged both Japanese rounds by approximately 300 to 400 meters of combat effective distance. The report continued with implications. The superior ballistic performance of American ammunition provides U.S. infantry with significant tactical advantages in open terrain and medium to long-range engagements. Japanese infantry, armed with Type 38 rifles, cannot effectively return fire against American positions beyond 450 meters, creating a gap where U.S. forces can shoot while our forces cannot. This represents a fundamental tactical disadvantage that affects infantry doctrine, unit organization, and expected casualty rates. Nakamura paused before writing the next section. This was the conclusion that would carry the most weight. Unless Japanese forces can match or counter this capability through tactical adaptation, improved ammunition development, or deployment of additional support weapons. Our infantry will face consistently unfavorable conditions in any engagement where American forces establish firing positions at medium to long range. The ballistic superiority of American ammunition amplifies the existing advantages of American semi-automatic rifles in rate of fire. Together, these factors create a combined arms disadvantage of significant magnitude. He signed the report, dated it, attached all the supporting data, velocity measurements, energy calculations, penetration tests, accuracy groups, photographic documentation of targets, everything needed to support his conclusions. The report went to Tokyo on May 23rd. It moved through naval headquarters. Copies were distributed to relevant offices. Technical evaluation committees reviewed the findings. Some officers were skeptical. The numbers seemed too decisive. Perhaps the testing methodology was flawed. Perhaps the sample size was too small. Perhaps captured American ammunition didn't represent average production quality. But other officers understood immediately. The Naval General Staff included men who had studied foreign military technology extensively. They recognized good engineering when they saw it. The 30-06 Springfield was a well-designed cartridge backed by sophisticated American industrial production. Japan had nothing comparable. The 6.5mm Type 38 had served adequately for 40 years, but that was against yet opponents armed with similar technology. Against American ammunition, fired from semi-automatic rifles, Japanese infantry were at a measurable disadvantage. The Imperial Japanese Army received copies of the report. Army ordnance officers reviewed the data with interest, but the Army's response was complicated by institutional factors. The Army had its own ammunition procurement system, its own arsenals, its own technical standards. The decision to adopt the 7.7mm Type 99 in the late 1930s had been expensive and disruptive, converting production lines, retraining troops, redistributing logistics. Another major change wasn't feasible in the middle of a war. Besides, Army generals argued, ammunition performance was only one factor in infantry combat. Japanese soldiers had superior training, superior tactics, superior fighting spirit. American materiel advantages were just mechanical. Spirit would triumph. But some Army officers weren't so sure. They had read the after-action reports from Bataan. They had seen the casualty figures. American firepower had been devastating. If that firepower was based partly on superior ammunition ballistics, then perhaps the technical reports deserved more attention. The Navy, however, took the findings seriously. Naval infantry landing forces would be facing American troops in future island battles. Understanding the enemy's advantages was critical for planning. The Navy established ammunition evaluation committees. More captured American cartridges were sent to Japan for detailed study. Naval engineers repeated Nakamura's tests. They verified his results. Everything checked out. The 30-06 Springfield was simply a better long-range infantry cartridge than anything Japan was producing. Could Japan develop better ammunition? Technically, yes. The ballistic principles weren't secret. A higher velocity cartridge with a heavier, more aerodynamic bullet would improve range and energy retention. But developing new ammunition required more than just technical knowledge. It required industrial capacity, specialized machinery, quality control systems, raw materials, time for testing and refinement, and Japan was already operating its arsenals at maximum capacity, producing millions of rounds monthly for an expanding war. Any new ammunition development would compete with existing production priorities. The report sat in files in Tokyo. It was read, it was discussed, it was filed away. The war was moving too fast for major ammunition redesigns. Japanese forces were advancing across Southeast Asia. The Navy was preparing operations in the Central Pacific. Combat effectiveness would have to come from tactics, from unit cohesion, from the fighting spirit of Japanese soldiers, not from ammunition improvements that couldn't be implemented quickly enough to matter. But the engineers who had conducted the testing understood. They had seen the data, they had fired the weapons, they had measured the results. The Americans had developed ammunition that gave their infantry a built-in range advantage. 400 meters, where American soldiers could shoot effectively, while Japanese troops struggled to return fire. 400 meters that would be paid for in blood in every engagement where terrain allowed long-range shooting. 400 meters that couldn't be closed by courage or determination alone. On June 12, 1942, Japanese forces landed on Attu and Kiska in the Aleutian Islands. The operation was part of a larger strategy to expand Japan's defensive perimeter. American forces in Alaska were limited, poorly equipped, stretched thin across thousands of miles of frozen coastline. The battles that followed were fought at close range. In fog and rain and snow, ammunition ballistics mattered less than stamina and cold weather gear. The 30-06's range advantage provided little benefit when visibility was measured in meters, not hundreds of meters. But in August, American Marines landed on Guadalcanal in the Solomon Islands. The terrain there was different. Open beaches, cleared fields around the airfield, some engagements would be fought at medium range. And there, the ammunition advantage would matter. Japanese soldiers attacking across open ground toward American defensive positions would discover exactly what 400 meters of extra effective range meant. They would advance under accurate rifle fire that began at 800 meters, 700 meters, 600 meters. They would try to return fire, but their bullets would fall short, would lack energy, would drift in the wind. The Americans would keep shooting, steady, methodical, each shot backed by cartridges that flew true at distances where Japanese rounds lost effectiveness. The battle for Guadalcanal would last 6 months. The casualty reports would tell their own story. Japanese infantry, assaults, stopped by overwhelming defensive fire. American Marines able to establish fire superiority at ranges where Japanese rifles struggled. The pattern that had begun at Bataan would repeat at Guadalcanal, then at Tarawa, then at Saipan, then at Peleliu, then at Iwo Jima, then at Okinawa. The same tactical problem, the same 400-meter gap, the same ammunition disadvantage that couldn't be fixed quickly enough to change anything. The mathematics of infantry combat are brutal and unforgiving. They reduce human courage and tactical skill to cold equations of range, energy, and probability. Japanese military planners understood mathematics. They had calculated logistics, fuel consumption, shipping tonnages, aircraft production rates. But the mathematics of ammunition ballistics had somehow been overlooked until captured American cartridges revealed what should have been obvious years earlier. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late 1942, combat reports from Guadalcanal confirmed what the ballistic tests had predicted. American defensive positions could establish effective fire at ranges where Japanese infantry could not respond. Marine units equipped with M1 Garand rifles were engaging Japanese attackers at 600, 700, even 800 meters. The Japanese soldiers advancing through kunai grass and jungle clearings faced a wall of semi-automatic fire that began long before they could shoot back effectively. Captain Tadashi Suzuki commanded an infantry company in the Sendai Division, deployed to Guadalcanal in October 1942. He kept detailed notes in a leather-bound diary that would later be recovered by American forces. His entries from late October described night attacks across the Matanikau River. "We attacked the American positions before dawn," Suzuki wrote on October the 24th. "Our artillery had bombarded their lines. We believed they would be disorganized. But when we advanced, their rifle fire began at distances where our Type 38 rifles could not reach them effectively. We fired, but our bullets fell short. Their bullets kept coming. Men fell before we could close to effective range." The next entry, dated October 26th, another attack, same result. American rifle fire is continuous and accurate at ranges where we struggle to return fire. Our soldiers are brave. They advance, despite casualties, but bravery cannot close the distance against such firepower. We need heavy weapons, machine guns, mortars, anything to suppress American positions so our riflemen can advance. But our heavy weapons are limited. Ammunition is limited. We rely on rifles, and our rifles cannot match theirs at these distances. Suzuki's diary entries stopped on November 4th, 1942. His company had been effectively destroyed in repeated attacks across the methodical. Of the 190 men who had landed with him in October, fewer than 40 remained combat effective by early November. Japanese after-action reports from Guadalcanal listed inadequate fire support as a primary factor in failed attacks. But fire support was only part of the problem. The fundamental issue was that Japanese infantry rifles, firing Japanese ammunition, could not generate the same effective range and sustained firepower as American weapons. Back in Japan, ammunition engineers were exploring potential solutions. If they couldn't quickly develop entirely new cartridges, perhaps they could improve existing ammunition. They experimented with heavier bullets for the 7.7mm Type 99, a 195 grain bullet instead of the standard 182 grains. Slightly more weight meant better ballistic coefficient, better energy retention at range. They tested various powder charges, faster burning powders, slower burning powders, different powder granulations. Some combinations showed promise. A 7.7mm cartridge loaded with a 195 grain boat-tail bullet and optimized powder charge achieved muzzle velocity of approximately 760 meters per second. Not as fast as the 30-06, but respectable. At 600 meters, this improved 7.7 round retained about 55% of its muzzle energy, compared to 48% for standard Type 99 ammunition. That was better. Not good enough to match the 30-06, but better. Effective range increased from approximately 550 meters to perhaps 625 meters. The engineers calculated that this improvement would narrow the gap with American ammunition from 400 meters to approximately 275 meters. Still a significant disadvantage, but less catastrophic than before. They submitted proposals for manufacturing the improved ammunition. The technical committee reviewed the specifications. The design was sound. The ballistics were improved. But implementation would require retooling production lines, recalibrating machinery, new quality control procedures, worker retraining, all of this while maintaining current production rates of standard ammunition to supply forces already in combat. The timeline for conversion was estimated at 8 to 12 months for full implementation across all arsenals, and that assumed no disruptions from American bombing or material shortages. The proposals were filed. Priorities went to existing production. Japan needed millions of rounds of standard ammunition immediately, not improved ammunition that wouldn't be available until late 1943 at the earliest. The decision was pragmatic, logical, necessary under the circumstances, but it meant Japanese infantry would continue fighting with ammunition disadvantages that translated directly into tactical vulnerabilities. In January 1943, American forces in the South Pacific had learned to exploit their range advantage systematically. Marine units established defensive positions with clear fields of fire extending 600 to 800 meters. When Japanese forces attacked it, Marine riflemen would begin engaging at maximum effective range, 800 meters, 750, 700, steady aimed fire. The M1 Garand's semi-automatic action allowed rapid follow-up shots without losing sight picture. Japanese soldiers attempting to return fire at these ranges found their Type 38 rifles inadequate. Bullets dropped too much. Energy was insufficient for reliable penetration, even when hits were scored. American tactical doctrine evolved to emphasize long-range engagement. Field manuals instructed squad leaders to position their men to maximize effective range, create killing zones beginning at 800 meters, force the enemy to advance through sustained rifle fire before they can close to effective combat distance. Use your ammunition advantage. make them cross open ground under accurate fire. Japanese tactical doctrine, developed during campaigns in China against opponents with similar weapons, emphasized closing distance quickly to engage with grenades, bayonets, and close-range rifle fire. But closing distance against opponents with superior range and rate of fire was extraordinarily costly. Lieutenant James Henderson commanded a Marine rifle platoon on New Georgia in July 1943. In an interview conducted after the campaign, he described a typical engagement. The Japanese would attack in strength, usually at dawn or dusk. We'd see them coming across open ground, organized waves of infantry. We'd open fire at 600, 700 yards. Just aim and squeeze. The M1 lets you shoot fast without losing your target. The Japanese would shoot back, but most of their rounds fell short or went wide. By the time they got close enough to be effective, we'd already broken up their formation. Their attacks always seemed courageous but futile. They kept coming, despite casualties, but they couldn't close the distance fast enough to matter. Henderson's platoon expended an average of 400 rounds per engagement. Approximately 60% of those rounds were fired at ranges exceeding 400 meters. The effectiveness at those ranges was what made the difference. Japanese forces attempting to assault his positions had to advance through 400 meters, where American fire was effective, but Japanese return fire was not. 400 meters measured in casualties, in broken attacks, in failed assaults that should have succeeded through weight of numbers but collapsed under sustained long-range fire. The ammunition disadvantage compounded other Japanese problems. Limited artillery support meant Japanese infantry often attacked without adequate fire preparation. Limited air support meant no suppression of American positions before assaults. The infantry had to rely on their rifles, and their rifles couldn't match American weapons at the ranges where combat was actually being fought in the Pacific. On Tarawa, in November 1943, the tactical situation was reversed. American Marines assaulted Japanese defensive positions. Japanese defenders had excellent fields of fire. Some firing positions overlooked open beaches with clear views extending several hundred meters. But the Marines were equipped with M1 Garands, firing 30-06 ammunition. They could engage Japanese positions from landing craft offshore, 300 meters, 400 meters, 500 meters. Japanese defenders with Type 38 rifles struggled to return effective fire at those distances. Marine combat reports from Tarawa noted that suppressive rifle fire from landing craft and beach positions was critical to the assault. We could engage bunkers from 400 yards out, reported Captain David Shoup, who earned the Medal of Honor at Tarawa. Our rifles had the range and the penetration. The Japanese fired back, but most of their rounds weren't effective at those distances. When we got closer, we had flamethrowers and demolitions, but the rifle fire at medium range is what let us maneuver. Japanese defenders on Tarawa were dug into reinforced positions. They had prepared for months. They had machine guns, artillery, excellent fields of fire. They fought with fanatical courage. But when Marine riflemen could engage bunkers at 500 meters with effective fire and Japanese rifles struggled to respond, the defensive advantage was partially negated. The Americans could shoot from distances where Japanese return fire was less effective, then close in with heavy weapons once defensive positions were suppressed. The pattern repeated across the Pacific. Saipan in June 1944. American forces landing against prepared Japanese defenses, but American rifle fire could reach Japanese positions from ranges where Type 38 and Type 99 rifles were marginally effective. Peleliu in September 1944, Americans assaulting Japanese cave positions. Marine riflemen could engage cave mouths from 400, 500 meters, suppressing defensive fire while assault teams maneuvered closer. Iwo Jima in February 1945, the most heavily fortified Japanese position in the Pacific. But even from prepared bunkers with excellent fields of fire, Japanese defenders found that American riflemen could deliver accurate fire from ranges where Japanese rifles struggled. By 1945, Japanese ammunition production was collapsing. American submarines had severed supply lines. Raw materials were scarce. Factories were being bombed. Quality control was deteriorating. Some ammunition produced in late 1944 and early 1945 showed significantly worse performance than earlier production. Powder charges varied. Bullet weights were inconsistent. Primers were sometimes unreliable. The industrial precision that was necessary for consistent ammunition performance was breaking down under the strain of total war. American ammunition production, by contrast, continued to expand. Lake City Arsenal in Missouri was producing millions of rounds monthly. Frankfort Arsenal in Pennsylvania, Twin Cities Arsenal in Minnesota, Denver Ordnance Plant in Colorado. American arsenals operated with ample raw materials, skilled workers, sophisticated quality control, and no threat of enemy bombing. Every cartridge met specification. Every lot performed identically. American soldiers could trust their ammunition completely. It would fire, it would fly true, it would hit at the expected range with the expected energy. The industrial dimension of the ammunition story revealed the same pattern visible across all aspects of the Pacific War. American industrial capacity was simply overwhelming. Not just in quantity, though American arsenals produced more ammunition than Japanese arsenals by an enormous margin, but in quality, consistency, and reliability. American ammunition was engineered to precise specifications and manufactured to tight tolerances. Japanese ammunition, especially late-war production, increasingly showed the strain of material shortages and industrial degradation. Staff Sergeant William Morrison served with the 1st Marine Division from Guadalcanal through Okinawa. In a post-war interview, he described the reliability of American ammunition. In 3 years of combat, I never had ammunition fail me. Not once. Every round fired. Every round hit where it was supposed to. I could engage targets at 500 yards and know my rounds would reach them with enough energy to matter. The Japanese would shoot at us from positions where their rifles couldn't reach effectively, and we could shoot back and hit them. That's not just about the rifle. That's about the ammunition. Morrison carried 8 en-bloc clips for his M1 Garand, 64 rounds total. He could engage targets confidently from 100 meters to 600 meters. Japanese soldiers with Type 38 rifles carrying 60 rounds could engage effectively from 100 meters to perhaps 400 meters. That 200-meter gap in effective range translated into tactical advantage in nearly every engagement. The American soldier could shoot first and shoot more effectively at medium ranges where most Pacific combat actually occurred. The Japanese military never solved the ammunition problem. By the time improved cartridge designs were finalized in late 1943, manufacturing capacity was too constrained to implement changes. Existing arsenals needed to maintain production of standard ammunition. There was no spare capacity for new product development, no time for the months of testing and refinement necessary to validate new ammunition designs, no resources to retool production lines while maintaining output of current specification cartridges. Some experimental improved ammunition was produced in small quantities. Naval arsenals manufactured limited runs of enhanced 7.7mm cartridges with boat-tail bullets and optimized powder charges. These rounds showed performance approaching but not matching 30-06 capabilities. Effective range increased to perhaps 650 meters. Energy retention improved significantly, but only a few thousand rounds were manufactured, not enough to equip even a single regiment. The improved ammunition remained a laboratory curiosity, while Japanese infantry continued fighting with standard cartridges that couldn't match American ballistics. Colonel Hiromichi Yahara, senior operations officer of the 32nd Army on Okinawa, wrote in his post-war memoir about the challenges facing Japanese infantry. Our soldiers fought with courage and determination, but they faced enemies with superior weapons, superior fire support, and superior ammunition. An American soldier with an M1 Garand firing 30-06 cartridges possessed advantages that our infantry could not overcome through training or fighting spirit. The ammunition itself gave them tactical superiority at ranges where modern infantry combat is decided. Yahara understood the mathematics. At Okinawa, American infantry could establish firing positions with clear fields of fire extending 700 to 800 meters. Japanese defenders attempting to emerge from caves to counterattack faced immediate rifle fire from ranges where their return fire was ineffective. American soldiers could maintain suppressive fire while their units maneuvered. Japanese soldiers had to either remain in cover or advance under fire they couldn't effectively answer. The final accounting of the ammunition disadvantage came not in technical reports, but in casualty statistics. Japanese infantry units in the Pacific suffered consistently higher casualties per engagement than American units, even when fighting from prepared defensive positions. Part of that disparity came from American advantages in artillery, air support, and tanks, but part came from the fundamental infantry firepower equation. American riflemen could generate effective fire at longer ranges and at higher rates than Japanese riflemen. That translated into more enemies hit, more enemies killed, more attacks broken up before they could close to decisive range. An American infantry company with 192 men carried 192 M1 Garand rifles capable of effective fire to 800 meters. A Japanese infantry company with 190 men carried 190 Type 38 or Type 99 rifles capable of effective fire to approximately 450 to 550 meters. In a meeting engagement at 600 meters, the American company could bring effective fire on the Japanese company, while most Japanese return fire fell short or lacked sufficient energy. The casualty exchange ratio from such an engagement favored the Americans decisively, not through superior courage or tactics, but through superior ammunition ballistics. Multiply that advantage across thousands of engagements, hundreds of battles, years of war, and the ammunition gap becomes visible in the strategic outcome. Japanese forces fought with extraordinary determination. They developed sophisticated defensive tactics. They built elaborate fortifications. They fought to the death rather than surrender. But courage and determination couldn't overcome the fundamental physics of ammunition ballistics. American bullets flew farther, hit harder, and arrived more consistently than Japanese bullets. That simple fact shaped combat outcomes across the Pacific. In the final months of the war, as American forces closed in on the Japanese home islands, plans were developed for Operation Downfall, the invasion of Japan. American planners calculated ammunition requirements for the invasion. Millions of rounds of .30-06, tens of millions of rounds for all weapons. The logistical planning was meticulous. Every soldier would land with basic load. Resupply would begin immediately. Additional ammunition would flow continuously from ships offshore to advanced supply dumps. American forces would never run short of ammunition. They would never face degraded quality. They would never fight with ammunition that couldn't reach enemy positions effectively. Japanese defenders preparing for the invasion knew they faced overwhelming firepower. Some military planners proposed issuing more machine guns and grenade launchers to infantry units to compensate for rifle ammunition disadvantages. But machine guns required more ammunition than rifles, and Japan's ammunition production was already collapsing. By August 1945, many Japanese units defending the home islands had limited ammunition stockpiles. Some had only a few dozen rounds per rifle. Quality was poor. Some cartridges from late 1945 production failed to fire. Others showed erratic ballistics. The atomic bombings of Hiroshima and Nagasaki in August 1945 ended the war before Operation Downfall was launched. Japan surrendered on August 15, 1945. American occupation forces entering Japan found arsenals with limited ammunition stocks. Some facilities had ceased production entirely due to lack of raw materials. Others were producing ammunition at a fraction of pre-war quality standards. The industrial capacity necessary to manufacture precision ammunition had been destroyed by 3 years of strategic bombing and resource depletion. American technical teams evaluating captured Japanese ammunition after the war noted the progressive degradation in quality. Early war production from 1941 and 1942 showed good manufacturing quality. Mid-war production from 1943 and 1944 showed some variability, but generally adequate quality. Late war production from 1945 showed severe problems: inconsistent powder charges, misshapen bullets, primers that failed to ignite reliably. The ammunition told the story of an industrial base under fatal strain. By contrast, American ammunition produced in August 1945 was identical in quality to ammunition produced in December 1941. 4 years of war production had not degraded American manufacturing quality. American arsenals in 1945 were producing more ammunition at better quality with better consistency than at the start of the war. The industrial gap between America and Japan visible in ammunition quality, reflected the broader industrial gap that determined the war's outcome. The story of Japanese engineers testing captured 30-06 ammunition in May 1942 is ultimately a story about industrial warfare, about how wars are fought not just with courage and tactics, but with engineering and manufacturing. Japanese engineers understood ammunition ballistics. They recognized immediately that American cartridges outperformed Japanese designs. They knew this advantage would translate into tactical problems. They reported their findings accurately, but knowing about a problem and solving it are different things. Solving the ammunition disadvantage would have required resources Japan didn't have: industrial capacity for new production lines, raw materials for specialized components, time for development and testing, stability in supply lines to distribute new ammunition. None of these existed in sufficient quantity while fighting a multi-front war against enemies with overwhelming industrial superiority. Japanese infantry fought the entire Pacific War with ammunition that couldn't match American cartridges at the ranges where Pacific combat occurred. That 400-meter gap in effective range existed from the first shots at Pearl Harbor to the final battles on Okinawa. It shaped every infantry engagement. It influenced casualty rates, tactical decisions, operational planning. When Lieutenant Commander Nakamura wrote his ballistic testing report in May 1942, he provided accurate data and honest analysis. His conclusions were correct. The 30-06 Springfield cartridge gave American infantry significant tactical advantages. Those advantages would persist throughout the war. Japanese forces would adapt tactics to minimize the range disadvantage, emphasizing close combat, night attacks, and prepared defensive positions. But adaptation could only mitigate, never eliminate, the fundamental problem that Japanese ammunition couldn't reach as far or hit as hard as American ammunition. The engineers at that Manila test range in May 1942 measured the truth with chronographs and target boards: 800 meters versus 400 meters, 60% energy retention versus 40%, consistent manufacturing versus variable quality. The numbers told the story. American ammunition was superior, and that superiority couldn't be matched quickly enough to change anything. By the time improved Japanese ammunition designs were ready for production, the war was already lost. American forces had landed on Saipan, had bombed Tokyo, had established positions that made Japanese defeat inevitable. Better ammunition in 1945 couldn't reverse defeats suffered in 1942, 1943, and 1944 with inferior ammunition. The lesson extends beyond World War II. Infantry ammunition seems like a minor technical detail, just brass cartridges and lead bullets. But ammunition performance shapes combat outcomes. Effective range determines where soldiers can shoot from. Energy retention determines what they can penetrate. Consistency determines what they can trust. Manufacturing quality determines what they can rely on. All of these factors combined determine who lives and who dies in combat. Japan's failure wasn't in the initial design of the Type 38 or Type 99 cartridges. Both were adequate for their time and purpose. The failure was in recognizing too late that adequate wasn't good enough against American engineering backed by American industrial capacity. By the time Japanese engineers tested captured 30-06 ammunition and understood the gap, it was too late to close it. The war would be fought with existing ammunition, existing rifles, existing disadvantages. Japanese soldiers would pay for that gap with their lives. In every battle, across every island, throughout the Pacific, 400 meters of range, 400 meters that American bullets could reach and Japanese bullets could not, 400 meters that measured the distance between American industrial capacity and Japanese industrial limits, 400 meters that helped decide a war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.